Ladies and gentlemen, please come have a seat. I'm going to introduce our last presenter. Some of you may already know him. It's Mark Duckworth from Baroid. He's going to do a talk on proper grouting procedures. Unfortunately, due to the time restraint, we do not have time for the constant pressure systems. I'm sorry. That'll be for next year. Just let you know. Something to look forward for next year. But anyway, any questions, concerns? If you do not have a brochure, they're here. All it is. I do not want your kids' names on it or your grandkids, but if you feel like you want to share, you can put your visa numbers on there, make sure they're valid. I will take it. No, I'm only kidding. All right, enjoy.
Thanks, Marty. Good afternoon. Can everyone hear me here? Because I like to move around.
No.
Well,
Grab that mic.
yeah, that is new to happen. Okay. Anyways, my name is Mark Duckworth. I'm the Baroid rep for the IDP group for Eastern Canada. And that, I've been around the East Coast for quite a few years, and it's been a good experience. What I'm going to be covering today is best grouting practices as per the regulation 382. And when I wrote this presentation, the first part of this presentation, or whatever, I'm going to be referring to the actual regs. You'll see it come up, certain slides come up there, and they're cut right out of the regulation, so you can see as I'm going along how everything's dovetailing in or applying. Okay, here we go. How's your day going? Well, actually, mine's been going pretty good. I don't know about you guys, but it gets to be a long day just sitting there when you're used to doing things. This is one of those days that, you know, sometimes you're glad you're not the other person. Okay, here we go. Can I use, that's hard for me to do because I don't like to stand still. I'm sorry I had Pepsi and a half. I'm ready to go right sideways. Okay, we'll try here. Anyways, safety moment. In every presentation we do, we're required company policy to have a bit of a safety moment. This one here is always be aware of your surroundings. In Canada, in the last month, with mass off of rigs, whether it's been water well, some coring rigs and things like that, we've had 3 strikes with power lines. And each one of the strikes, when they did the assessment, analysis of the job site and that, it all came down to one thing only. The people said they didn't see them there. They weren't aware of their surroundings. No one got hurt. One guy got burned bad from an arc, but that's about it. And it's one of these things when you're dealing with your mass on rigs or things like that, or even equipment. You're digging some trench or something like that. You've got to be aware of what's above you and also below you. Okay. We've done our safety session, we're good to go now. Okay, for examples of grouting, this is going to kill me to stand in one spot, but here we go. Okay, this is just a couple of these slides I've pulled out of different presentations I've used across the country and that. And this one here is examples of poor grouting. And then the problem here is you got no grout to surface. And believe it or not, these are actual from job sites. These aren't staged or anything like that. The next thing is non-concentration placement of the casing, or concentric placement of the casing. If you don't have your casing centralized, I don't care how good or whatever your pump is, or what you're pumping, cement or bentonite or combination, whatever you're doing, you're never going to get a proper seal. If your casing is touching at any point within usually about the top 20 feet, if it's up against the formation somewhere in there, you're going to have seepage and you're going to wind up having contamination into your well. The cause of this is poor grout selection, and that's a big part of when you get this type of situation happening. Improper grouting technique, we're going to cover that a little bit later on. And sloughing due to geological conditions. Putting in the wrong material because of the conditions that you're in. And we're going to be covering that, when and where to be placed and using certain materials. Impact, contamination to the aquifer well. Very straightforward. Runoff, small animals, insects, so on and so forth. Basically, you have an issue on your hands for no reason. The next one, and this one here is from an older well. The cap was taken off. Just there was a Burma cap on top, but this was when they were getting ready to do some work on a well, but just a subsidence around it. Problem here is poor annular seal. If you get subsidence like that in anything, and we're just talking generically, I don't care what you're grouting with. If you're getting that type of subsidence happening, you didn't have a proper seal when you first put it in. The grout job that you did, for whatever reason, wasn't done properly. Because when they settle like that, cement settles a bit or whatever, that's fine. You gotta top it up. But this is after a couple of years, this is happening, and this is due to crates at the end of the day, a poor annular seal. No cap, that one there, that was put in there just to make sure that everyone was staying awake. And then poor grout selection, and then improper grouting technique, same deal. Get a lot of pocketing. If you get pocketing in the air, if that type of thing happening, you will get subsidence happening. Backfilling, if it was a trench or something on those, in that case it wasn't a trench, it was actually a grout with trimming line that they did. But if you were digging, say, doing some pitless or something like that, and you didn't backfill properly, right around your pitless and that, you will get subsidence happening. Impact, basically over time, what you do is you want to get a washout and collapse. Okay, regulation 832. Out of the definition section, what I did was I pulled the pieces that contain the grouting, because that's what we're going to be covering. When you get into the dug wells, apron, which means the impermeable seal made around of either concrete or bentonite that surrounds the dug well casing. I'm going to be referring to these, but this is just to kind of get us going. Grout, and this is their definition straight out of the regulation, so I didn't write the regulation, these are the government words. Grout means a stable, impervious bonding material, that's critical, that is capable of preventing vertical movement of water. Number one, along the outside of the well casing, between the well casing and well liner, and then when you decommission a well. And then the last one that in the regulation, or on the definition side, that applies on the grouting side, which we're going to be talking about today, is high solid bentonite grout means a type of grout consisting of a mixture of powder or granular bentonite clays, and bentonite and clays are the same thing, and water that contains at least 20% bentonite solids by weight. And it doesn't matter where you go in Canada, 20% solid is what is required when you are going to be grouting off or sealing wells. Okay? 101 is 20% solid. Yes, you can make it where your grout is 16%, or you can drop the percentage of solids in your grout very quickly. And the easiest way to do that is the old-fashioned dilution. Add extra water to thin it out so you can pump it down a smaller trim line. That is, and when you, at the end of the day, that is how you get a lower percent solids. The way we check for solids, if someone's coming out, or there's an inspection or an issue or whatever, is they do density tests, weight. And that's how they figured out. There's no ifs, ands, or buts. It's a balance that we use, or any inspector uses just a straight mud balance, and it's done by weight. And they go by manufacturer spec, and there's a tolerance in there for weight, 30%, depending on what the product is you're using. And then that's how they figured out whether you're light or you're on light. Okay, soluble sealing materials have low permeability, and they're generally around 10 to the negative 7 to 10 to the negative 9 centimeters per second. And that's the movement or infiltration of outside contaminants inwards towards the casing. That's where your seal is. That's very, very slow, and we're talking extremely slow, years and years and years to get any movement. Capable, and this is very critical, this is the part that a lot of people, they overlook. They just say, well, I got in the hole, it's going to happen. Capable of bonding with the casing and the borehole, forming a permanent watertight seal. That's it. That's what a true grout, and I don't care what kind it is, what manufacturer, that is what a grout is. Anywhere in the world, that is what a grout has to do for you in order to do the job properly. Uniformly distributed around the casing to facilitate an effective seal. Under the reg here requires, and this is, you'll see where I repeat things, but there's certain things that are very important. Requires grout to be a minimum of 20% solid. So if you're cutting her back, your cement or whatever, so you can pump it, you're actually below the regulation spec. Materials, and this is 20% is you can go down to, there are grouts that are designed down to 16%, but that would be more or less a temporary, something that you're grouting and you're going to be yarding out, cleaning that grout out. You're just sealing it temporarily, like for a week or two, and then you're coming back in when you do something like around 16%. Everything else is 20% or above it. Wells that are specifically engineered or designed are anywhere from 30 to 80% solid. Those are specific jobs where you're dealing with contaminants or there's commingling aquifers that they definitely want to keep separated out. Is where you get to the 30 and 80%. These designs are based on the scenario standard of particular job. Soil formation place and the degree of permeability. The higher the solids, the more permeability, or the slower they need anyway, the ability of the outside zones to migrate. 30% is typically if you're doing a monitoring well or municipal well. Most municipal wells, if it's for a large system, require a minimum of 30% solid. And that's still a pumpable grout, but it's a lot heavier. Big difference when you start to pump. 70% and stuff like that is for geological applications requiring high structural integrity. Bentonite doesn't have any structural strength to it, as in cement, supporting strength, but it will hold and seal. And the higher your solids content you're going to get in there, the more structural integrity or the stronger it's going to be supporting load. Okay, now I've divided the presentation into two sections. The first is the drilling and construction, disc wells, and the second part is on dug wells. First part, section 21, I'm just going to go through these really quickly, just as a quick overview, and then get into where the grouting and all that comes into. A well casing, this is for section 21.1, and I'm just going to go through them quickly. A well casing must be installed in each drilled well. A well casing, well liner, or well screen installed in a drilled well must be installed so that all the following requirements are met. The well casing is at least 6.1 meters, and for old-fashioned people like me, that's around 20 feet. Well casing extends at least 152 meters above the ground. So you've got to have your stick up at least 6 inches. There's a minimum annular space of 1 inch outside the well casing, and in between the well casing and the liners of different well liners of different diameters. Okay, they want the 1 inch because with a 1 inch you can at least get in there and grout. It's going to be tight, but you still get a trimming line down there. Okay, a well casing is adequately sealed and prevents water or any other substance from leaking into the well from an annular space, the drive shoe, or the well casing interface of subsurface geological material. Switch. And just a second here. Installed. Okay, for steel casing, a drive shoe is to be attached to the bottom. And that's one thing that you're, one of the few provinces that is stipulated that drive shoes have to be on the bottom of the steel casing. And that was one thing I found interesting about your regulation. Except when using remediation, a well under clause G, a seal of high solids bentonite grout or other grout extend upwards to the annular space to at least 1 meter above the base of the casing and seals the annular space. That's what you have to do. For a well liner that is installed to repair or modify an existing well for water contamination, a seal of high solids bentonite or other grouts extend upwards the annular space from the base of the well liner to as near to the surface as possible. One thing when you're using bentonites, if you want them to remain active and do their job, they cannot be exposed to sunlight for a long period. They dry out. It's like a cornfield. And that, when it dries right out, and then it rains, it heals itself up. That's what bentonite does. It'll start to crack, and then when the moisture comes back in. So if you're ever gonna run bentonite to surface, is you always wanna put 3 to 4 inches of soil over top of that bentonite, and that will be enough of a seal to keep that from drying out, splitting, and getting any micro fractures in there. Okay? And then the last thing here, any remaining volume of the outer borehole annulus is filled in with grout, drill cuttings, or impervious soil to the ground surface to prevent the surface water from entering the annulus space. In other words, mounding up on the top. Fill it up. You're allowed to mound it using drill cuttings or soil or whatever over top of your grout. Okay, a casing, a well casing is welded, otherwise connected to well screen used. Any natural manufactured filter pack material used in the conjunction with the well screen are developed for installation and may be material suitable for potable water applications. Question to you guys up there. How thick of a filter pack can you put in on the outside of a screen that you can clean at any time? How thick? 7, 8 foot? What is the maximum that you can actually surge and swab and clean a filter pack? This isn't a trick question. This is from anything over 7 inches for a filter pack. You're gonna, if you're going to be cleaning, you have to go back into the well years later, whatever, it's starting to plug off. You want to surge and swab. Once you're over the 7-inch spacing on the outside of that screen, the formation, you're not going to have much, you will not be able to get your chemicals past the 7-inch mark. 7.5 inches, I don't care how much horsepower you put down there, unless you destroy the screen and blow out the filter pack, you won't be able to clean any deeper than 7 inches. They've tried it, they've used horsepower, they've used air and everything else like that. To get the chemicals back, if you have to use an acid or something like that, you got some slime happening down there, or you're getting some contaminants one way or another over time. A 7-inch filter pack is about the maximum you can thoroughly clean and do a proper job of it all. Any additives such as water stabilization muds or foam used do not contain a toxic substance. I'm going to cover the environmental side of this at the very end, but right now, if you're doing in the water well industry, anything you use and it's part of the reg, it has to be NSF. And I'm going to explain that with a couple slides on NSF, what it's all about, so everyone understands what to say and what not to say. Or in a lot of cases, people misinterpret the words that what NSF stands for. Okay, we're going to, for a drilled well, pretty well, the main thing that they discuss in there is they talk about bentonites. And I'm just going to cover bentonites here. Cements and that I'm going to cover on the side when we do the dug wells. Advantages and disadvantages of bentonite, and this is 20% slurry minimum, and it's a minimum I'm putting in there. Okay, expands up to 9 times its dry volume when exposed to water. Okay, expansion force into the open annulus spaces in an annulus. Basically, one thing about bentonite, the difference between bentonite and cement, the way that it's set up, is when bentonite sets up, it absorbs water. It's a sponge. It's clay and it's soaking up water. That's why it swells up. When cement sets, cement displaces water. That's the difference between the two products. That's why you can get a little bit of shrinking or subsidence when you're putting in cement, is because when cement is truly setting, whether it's out of a bag or it's come from a plant, cement displaces water. That's how they're set. Bentonites absorb water. Two different reactions that you're going to have happen down the hole. Okay? Bentonites are faster setting time than cement. That is true to a point, because you can, and we'll get into this in a little bit, you can set up cement very quickly. Within 3 to 4 minutes if you want. You can do that. And that's with chemicals, it's pretty easy to do. I've done it, and I wouldn't do it again. Just because when you start playing with that, cement is all about chemistry. It's not in its formulations. That's when you're getting to doing anything with cement. Will adhere to both walls formations. Bentonite will stick to pretty well anything out there. It doesn't matter if it's fiberglass, PVC, steel, it'll stick to it. Any type of formation, it'll get in there, and because of its nature of pushing out as it's starting to set up, that's where it gets a really good bond with formation, different formations that you go through. Okay, not biodegradable. Okay, we're going to cover that in the environmental side in a bit, but that's a very key issue about bentonite. Because what's bentonite? Clay. Sodium merlinite. That's a fancy name. It's about the only big word I know. But long story short, bentonite is just clay. It's a type of clay, but that's what bentonite is. Okay, will not alter downhole temperature, very critical. Easy application for pump installers, and that's when you're doing the thickness. Bentonite is very easy to work with. Because you got to remember, bentonite isn't always pumped. You can use pellets, you can use whole plant, you can use dry material. You just got to wet it as you're installing it. Can be mixed with cement. I'm going to get into that when we talk about cement, about mixing bentonite. Okay, and the disadvantage, it does not have any structural strength. Okay, like with bentonite, you can't get it to set up and then go running across it and not go through, because you'll leave footprints, I guarantee you. May dry out if it's not protected. That's why I'm saying you grout the surface, and then you have to berm it with some type of a soil or whatever on that. If you want to put a cement cap on, cement is calcium-based, bentonite is sodium-based. They don't get along that well. So what you have to do is you have to put a bit of a layer. You have to put, if you're going to cap a well with cement, let's say you grouted it up, you put cement in there, is you should put about 1 inch of sand between the cement and the bentonite. The cement will move down and migrate, the bentonite will come up, but as long as the two surfaces are not directly in contact with one another, you'll have a constant seal. They'll bond. The cement will bond with the sand, and the bentonite will bond with the sand, but it's like a buffer area between the two of them, and you'll get a proper seal. Still have a proper seal. Big thing with bentonite is that, and this should not apply to any water well unless you're on a decommissioning because the well is contaminated, but you have to be conscious of the contaminants that are in water, like decommissioning for a bad well or something like that. Water does play, the type of water or contaminants in the formations. If in some places it'll just retard the bentonite from setting up. Carefully, and this goes into the same thing, if you're installing a well in the springtime on a busy roadway where they're spraying all the calcium chloride and they are spreading a lot of salt or whatever it is, I'll be quite honest with you, the top portion of it is not the spot you want to have bentonite, because calcium chloride and high chloride salts do not get along with bentonite. They don't. They degrade them, break them down. Okay, they come in several different forms: powder, granular, chips, pellets. I'll just go through it. There's two types of pumpable grouts, and that a dispersed bentonite grout are those grouts that have various additives put in them. And what it is they grind it up to a certain size, the bentonite to a certain size, and then as it's going down the conveyor into the dryer, to dry it down to the percent moisture, they spray retarders on there to slow its ability to hydrate. And that's things like that they're called one-step grouts, and the ones that we have are Quick Grout and AquaGuard. You just take the bag, put it in the water, and there's retarders on each side of each sprayed and dried onto the pellet or the granular, so when it hits the water, it has to be washed off by the paddles as it's moving around in your mixer, and then when it starts to wash off, it starts to hydrate. For it to truly set up, the setting time for those type of grouts for a 100% set is around 24 hours. You can working time, the working time where it starts to go into its set stage is anywhere from 5 to 7 minutes from the time it's introduced to the water. So when you're grouting, all grouts are 7 to about 9 minutes, depending on what their setters are in their formulation. But the 24 hours for a true set on that. And that means where it's set and it's good to go, and that's the end of the ballgame. Inhibited grouts or dispersed grouts. This one here is where you it's a two-stage system, and that's where you'll have your water, treat your water, then you're gonna put a polymer base in there, which something like a liquid polymer in there is your inhibitor. You're actually doing it yourself mechanically. And then after that, you put in a raw bentonite, unbeneficiated, means absolutely zero additives. It is ground to a certain size, 80 mesh typically. You pour it in there next. When the two get mixed around, the polymers stick to the bentonite, slowing its hydration rate, and then you pump her down the hole. That one there, the set time, because you're mechanically doing it, you're actually washing, you're installing the polymer onto it in the process, it doesn't get a long time to bond with the bentonites, so they set up a lot quicker. These ones still have a working time of, what do you call it, 7 to 9, 8, 9 minutes, around there, same as a one-step grout. The big thing is that their set times are quicker. When they start to set, they set. They're very good at plugging Tremulite. There's 1 to 2 steps. One is an easy seal. That's one that's is like Bensil Easy Mud combination, but it's one that goes through the conveyor system. It's a one-step grout, but it falls under the inhibited section where it has a higher polymer ratio of polymer on there. And it works the same thing with Bensil Easy Mud. Yes, sir.
What happens with your gold, your Bensil, or your steroid gold anyway? With it, because there is inhibitors in that, from setting out. What helps suspend your scent?
When you're doing a geothermal?
Yeah.
Grout? Okay, when you're doing any type of grout for geothermal, when you put your bentonite in there, the bentonite is only a carrier. Okay, the sands are what are there for the what do you call it, for the conductivity. And when the sand is introduced, the bentonite's job is just there to do the suspension. And it has a bit of a retarder put on there. So what it's going to do is, once the bentonite is hydrated or whatever, what it does is it starts to lock itself into formation, and that's how it pulls all the sand up.
So it can last a retarder on your other ones?
Oh, yes. It's not, it is something that you always want. If you're going to use a grout that is designed for geothermal, you're going to be adding solids, sand, your silica sand. If you're not going to be adding any silica sand to something for a geothermal system, you want to use just a standard grout. Because grout, bentonite by itself is 0.4 conductivity. Okay, we'll just keep this simple and not get off topic too much, but once you start adding solids, or a grout that is designed to carry solids, other than just its bentonite itself, like the silica, and then that's where you build your conductivity, and it goes up 0.64 to 88 and so on and so forth. But if you're just doing a well, do not use a straight bentonite grout that is designed for geothermal and carrying sand by itself. It's too thin because it's designed to support, right?
While they're having it marked on there, where its conductivity is
Point-
without anything, like it's 0.46.
Yeah, and that's any straight bentonite is that, because some places where they have strict solid, like Canadian Shield, where it's solid rock top to bottom, and they want to put, it's a very easy one and light one to pump. It's like pumping a heavy drill nut. And that's why guys use it, because they can pump it very quickly and very easy.
But you're saying it's not recommended to use it?
Myself, personally, no, I don't like it just as a standalone.
Just because it's permeable?
It's not the permeability, but what it is, at the end of the day, it doesn't have as much structure to it, because it's a finer powder. It's like a 200 mesh quick gel drilling nut. That's how fine it is. The finer it is, the less structural integrity you have to it. That's why you want to have a grout is a certain size, like it's a larger size, you're going to get a stiffer material in the hole. And I just find it does better. It sets up quicker, and at the end of the day, it just tends to do a better job when you put a heavier grout in there if it's just straight grout.
So what's the Baroid product? What's the thing between the Bensil and the Baroid gold?
Well, you've only got basically an inhibited and dispersed, and the dispersed is going to be something like a quick grout. The other side of the coin is something like an easy mud. And then after that, you're into geothermals, and that's where you go into the barrel. And that's your 3 choices out there for any type of grouting. And please do not use a geothermal grout for grouting water wells. Remember, you don't have your 20% solids when you're doing that, because it's very light grout. It's a suspender. Working with bentonite grouts, okay, inhibit grouts are designed slow rate of hydration, just long enough to place down whole. Paddle mixers, 101 guys, you gotta have paddle mixers when you're doing these. Shovel will work, I guess, if you want to do it that way, but you can't use any other pump to mix other than paddle mixers. The more abrasive the pump, the faster your grout is going to start setting up in your tank setting. You cut your work time down. Best way to determine your percent solids or density with these types of grouts is accurately measure the amount of water for each batch. And that's it. That's the 101. That's, if it says 24 gallons, US gallons or whatever, X number of liters, that's what each batch has to be. It can't be, well, we'll put this, yeah, that's about right. You mark it on your tank or whatever you're mixing in, and that's your fill line every time. Simple as that. You do it once, mark it, you're good every time you're going to grow. But if you're doing the guess game, you're going to wind up plugging tremmy lines, you're going to be inconsistent in your grout, and you can get sloughing happening, sediment. Because if you put a heavy batch, light batch, or whatever, it's not consistent, your grout is not going to set up all the same, and you're going to wind up having subsidence happen. Okay, take time to calculate the correct volume. And we'll cover that really quick down the road here. Calculating correct volumes. Okay, plug-in pellets, approximately 70% solids. These are the one of the easiest things. Typical bag, 50-pound bag is 0.7 cubic feet. When you're dealing with pellets is a finely ground bentonite, and they use these in environmental quite a bit. All it is a 200 mesh ground through, and they're put through plug screens, basically through a press, and that's how a plug is made. And then they're cut to length. Uncoated, which is just the ground up, put through the screen with a binder to hold it together and stuff. Your working time is about 30 minutes by the time it hits the water and settles down. If you use one with a polymer bait, a coating on the outside of it, you have about 60 minutes. Their set time, and it comes down because you've got to remember, bentonite is a sponge. It absorbs water. So if the water is really good, low contaminants, low calcium, whatever in there, you'll have a set time, 2 hours, no problem. But if you get into stuff where there's a lot of contaminants, and that's what extends your setting time, is when you got a lot of contaminants, it's up to 8 hours. Okay, on the dug well side, and I just took these parts out of the actual reg or whatever, and this is the side that I want to put in there. A well casing must be installed in each dug well, and that's critical. And this is the first part of the whole regulation that actually, at the end of the day, states what you can use, and the list gives you an option. On a drilled well, it's bentonite. That's the only thing in that whole section 21, I believe it is, that it says bentonite, bentonite, bentonite. It does not mention cement whatsoever. I don't. And the regulation, it's right up here. It's what I was told with regulations, because I deal with each provinces. It's all up to the interpretation of the user. The annular space above the apron is filled to the ground surface with one of the following to prevent surface water from entering: cement grout, concrete, bentonite or other clays, or commercial grout. Okay, simple as that. That's what it is. On the other side, pipes connecting the excavation are filled with one of the following, and they list the same thing: cement grout, concrete, bentonite or other clays, and commercial grout. Any additives used, such as water stabilizing mud foams, do not contain any toxic substance. This is where in the definition section this comes in. It's critical that if you're using anything in the water well industry, and at the very last part I cover this, but you gotta make, and I know everyone does here, but I can't specify enough that you make sure that it falls in compliance on the environmental side. I've had a couple issues in the far north where they ran out of stuff and they decided to improvise. And the wells they were doing, we had to cement them off. They were classified as contaminant before we even got them online, just because of the products they use. So I can't say enough that if it's not within the realm of drilling products out there and certified products that are out there, don't use it. Because it was just, there was no reason for what happened, but it did. The guys were straight down, we ran out and this is what we did. And they pumped the wells, they tested. There was a little bit of residue in the gravel pack down there because they were running the bear and some other agents. And the thing is it blew so far into the formation, they said it was contaminated, and they wound up cementing everything off. Okay, on this side of the thing, we talked about bentonites. And on this side here, what it is we're going to cover the cement side of it. Okay, the cement has a greater density than bentonite. It is easier to place. Cement will flow anywhere for you. If you want to modify it by adding something into it, whatever you can. It has structural strength, and it resists many common contaminants. The one thing with cement is you can fool with set times or whatever, but I don't care what additives and how fast you have your cement setting. Cements should be allowed to set a minimum of 12 hours before you do any work on or around it. Because at 12 hours, a cement is not fully cured, but it has enough structural integrity and bonding already happening chemically that it will hold together. You're not going to create any damage. The longer you leave it set, the better off you are. When setting is, and this is critical, I actually had several disasters in this area here. When setting is generated, heat, which expands metal casings, may cause seepage over time. The faster a cement sets, the more heat it generates. And that is why if you're doing a lot of stuff, especially around PVC, and it's in the next couple slides, what you want to do is you want to put a retarder in the cement. You add it right there on site. You don't add it. You bring it in by a truck. You'll see the guys put little baggies in the back of the truck just before they start to pump. And what that is a retarder. And it slows down the setting time of the cement, especially if you're dealing with fiberglass or PVC. And at the end of the day, you won't have any issues of collapsed PVC. I've had a couple of those jobs where they're supposed to be bentonite, but the foreman figured it was better and quicker if we just back up a truck and start pumping, which they did, and they wound up collapsing the casing and having to drill it out at their expense the next day. Because what happened is they called the cement company, they told them what they were pumping or what they needed, want a good flowable, but got to have it set up by the morning. So the guy came in there, he put a setter in there, it went down whole, but it basically melted the PVC pipe. That was the end of that ballgame. Cement degrades over time, and some concrete aggregates, the aggregates that they add in there can cause cracking. Freezing and thaw cycles with cement, typically towards the surface, if they get any type of a crack in them, you can have some issues. Needs to be topped up. And remember when I said cement sets, cement shrinks. And it does. It doesn't shrink, sorry, it displaces water. When it displaces water, it's losing volume. That is why you have to go back and usually top them up. Okay? High filtration rate results in poor bonding and increases in settling. And what that is filtration rate is at the speed at which the water leaves the cement when it's in the set stage. And you can play with that. It's not too hard to play with, but that's one of those things that you have to be aware of. Mixing cement, one thing is you got less than 2,000 ppm of totally dissolved salt. In other words, if the water's pretty reasonable, you can get away with it. One thing that will offset cement is if there's any type of a residue from a hydrocarbon or even a trace hydrocarbon around, some grease or something like that gets in there, that will mess up the batch of cement. Okay, high pH, and this is the thing, if you're pulling from a treated system or whatever and it's got high pH, and that, what it'll do is it increases the set time, it speeds up the setting time of cement. It's very rare, but sometimes in some of these municipal places that people are pulling off of, filling up the water trucks or whatever, and then out to a job site, if it's a brand new subdivision or house that's being built in the middle of nowhere and there's no water around, they take their own water in or fill up on the way. Sometimes these newer systems that are out there, they're treating the water a bit and the pH is up. And guys are having issues with the setting up the cement when they're using cement. It's always, no cement is any good in any situation if you have any lumps in it, because the lumps are dry inside, and basically if everything sets up and there's a big wad in there, then inside that lump is air. There's pocketing, and then you're going to have issues down the road. Okay, paddle mixers using progressive cavity pumps or gear pumps are most common for placement. When you get into piston or diaphragm, these can be, a piston or a diaphragm can actually be used for mixing cement. You can get away with that. A progressive cavity or a gear pump, no. Progressive cavity or a gear, one of those things, they have wear, the stainers get worn very quickly when you're pumping cement, and they have limited ability to develop enough pressure to move, to trim long distances, whereas a piston or a diaphragm, sucked in the chamber, pushed out, away she goes. Microannulus, in that if you're mudding up or even using heavy foams and you're going to cement right afterwards, you want to try and make sure if you can, if you're going to cement or whatever, is to try to get that out, blow the hole or flush it before you start the grout, because if the bentonite gets in there along the formation, what it is the cement will not move through a filter cake, and over time that filter cake or the bentonite seal, the wall that you created when you drilled that hole, will start to break down and you create your own microannulus. Also, casings, you got to be conscious of the casings. Steel, added heat expands the casing, dissipated heat causes the casing to contract. Over time, when you start your grouting in that, the thing is as long as things go to set and do everything in a very slow cycle, then you're not going to have any issues with the bonding. But if you have it where it flash sets or you're playing with the setters in there, that's when you're going to wind up having some real issues with microannulus. Okay, PVC, and this one here, warp distorts the pipe. I personally will not go on the job now. I've learned my lesson that if you're using PVC pipe and they want a cement, I don't want any part of it, because a lot of the time guys are mixing their own cement, and when you know it's X number of batches, but I've always, and I've only had one well that didn't, but I've always had issues with the cement and that on the expansion, just with stock cement and that, and getting some warping or some issues with seals where they join together if you're putting PVC in sections. Cement accelerators, all they do is speed up the set time of cement. Calcium chloride is the most common. Powder flake, and here's the thing right here. 2 to 4% by weight of cement is recommended concentration of an acceleration cement slurry. And what that is if you're going to add any calcium chloride, it's 2 to 4% by weight. There's no advantage. Guys figured, well, we're going to put a little bit more, up to 6%. Once you've exceeded 6%, you're at the point, people, I'm going to be very honest with you, you might as well just call it a day and start another well. Because the cement will either set up on you before it comes down the chute or goes off the end of the wheelbarrow, or what it'll do is you will get so much heating down along your casing, you're going to have a microannulus. It doesn't matter. You're painting yourself into a corner. Standard, if you're using a sack of cement, it's 0.8 to 1.6 kgs, or 1.8 or 4.5 pounds per sack of cement. That's an 88-pound sack of cement. Accelerators with cement at low temperatures are very unpredictable. Because cement is a chemical reaction in there, if the temperature is really cold out there and you're using cement and you put an accelerator in there, the combination of the two of them just turns your cement sideways, but you're not going to have a proper set, or 10 to 1, you're not going to have a proper mixing. I always tell people, if you're doing the cement side of it, especially when you're doing with any volumes, is when you pour your first batch, take a sample and set it aside, right on the side, the time that you started your cement, then you'll know how your set's going. Very quickly, how well it's setting up. If you use too much, once you get around the 6%, the calcium chloride's at a concentration, it can cause corrosion problems. This between 4.5% and 6% calcium chloride by weight in cement. It's been proven over the years that if there's any marks or scoring or nasty marks on the steel or whatever, scratches, not scoring, but scratches where the outside, what do you call it? The outside, we'll call paint or whatever, is removed, and that where there's steel exposed, you'll get corrosion. The big thing is just follow your manufacturer's spec. Bentonite cement. Now this is my pet peeve. This one here, but I gotta put it in to be fair to the whole deal. Bentonite and cement grouts. They're easy to pump, easy to clean up afterwards. They're Cadillac to clean up. Bentonite can be used in concentrations up to 5% by weight. And anyone that's put bentonite in with their cement to do whatever you think it's going to do, and I'll explain what it doesn't do in a second here. Once you've exceeded 5% by weight, you basically have got garbage down the hole. Because cement is a sodium base, is a calcium based material. Bentonite is a sodium base. They don't get along. The only reason, and this is the only reason, that bentonite was ever introduced to cement, and I know you guys do deep wells around here, but I don't know anyone around here that's pumping cement 15, 20,000 feet. When you add bentonite to cement, it acts as a lubricant. That's from the oil patch. That's where that comes from. When you put, for what you're doing in a water well industry or water well application, yes, you can do it. But the thing is unless you are pumping, I would say anything over about 12,000 feet, there's no reason, choose my words carefully, we're being recorded, but there's no reason in this world that you need to be adding any bentonite in it. That comes from the oil field, that was adopted from the oil field, and I'll tell you right now, it really, realistically doesn't do you any good. And if I were to say, ask people, and they say, yeah, we do it all the time, I'd say, okay, when you do your batch, how many gallons? Well, I don't know, we have 100 gallons. Fair enough. And I say, well then, how much bentonite are you putting in there? Well, we put 1.5 buckets. Well, how much does that weigh, by weight? If you're not measuring it out, and being within that up to 5% by weight, then your cement's going to have issues, the whole deal. You're wasting your time. Okay, basically, and this slides in your handouts there, increase of 2.4 liters or 0.65 US gallons of water per percent of bentonite added is necessary for dry blending applications to obtain a consistent mix. If I have to, and I do in certain jobs, I'm doing one right now actually, and what it is they require this bentonite. We've had a few words over it, but this is the way the engineer designed it. This is the way it's going to be done. Is what I do now is I pre-mix my bentonite in a tank. I've got a hopper of 100 gallons, and then when we mix our cement in this batch here, and then we measure it out, the bentonite, after it's already hydrated, remember it absorbs water to do its deal. Bentonite displaces, well, when that reaction happens, everything goes sideways. But what I found is if you already have pre-hydrated your bentonite, mixed it all in the batch in there, and then you add it to your already existing cement mixture, deducting the water out, you can get this stuff to go and you'll have a more consistent and better cement job. If you dry blend it, if you don't do it properly, you're going to have issues. One dry quart of 200 mesh bentonite, which is powder, okay? It's 0.6 kgs or 1.8 pounds, and you'll see what this is all about in a second. Does it help reduce shrinking? The answer, from my experience and what I've learned since I started this game, yes, the answer is no. It doesn't reduce the shrinking factor. Okay, this was done this was done years ago. This, we sent out a questionnaire to all manufacturers of bentonites and cement companies and that, and we said, realistically, if you were to try and seal up these formations or do something, how would you rate them? And this was the averaging that we came out with this chart. Unconsolidated sands, gravels, and then consolidated gravel, packed sand, clay, competent rock, fractured rock. Wherever there's a question mark there, that's kind of iffy whether you're going to be using those materials. When you get into chips and whole plug type thing, chips or pellets, because they're the size of them, 3/4, 3/8 in size, and that they go across the board, they'll seal up anything. Cement and that, if you really want a cement to work, or so you're not just pumping and buying shares on Lafarge or whoever you use, the thing is at the end of the day, good competent rock or something with structure is the only place that really cement is going to do you any good, because it runs so much. And then if it's not, if you're not going to have it, if you're going to start playing with the flowability of cement, you've got to start putting additives in there or solid sand, something like that, just to change it. Okay, this just gives you a rough idea as to where everything is rated. Okay, the only thing that I want to point out here is if you're going to be adding a bentonite to cement, please remember this. You have to use, and this is a big word, but it's very simple, an unbeneficiated bentonite. That means a bentonite with zero additives. It's the bentonite from the mine, dry, ground size, and backwards. There's absolutely nothing, no additives to it. Ours is called Gold Seal, but there's other manufacturers, they have intended to use something with no additives. Remember, bentonite have additives put to them. They have, and mostly they're polymers or extenders put in there to change their structures or the way they behave when they hit the water. Those polymers tend to turn bentonites wonky, cements wonky. They can turn them into pudding if there's too much polymers in the actual bentonite that you're adding to it. If you add weights, if you're not measuring how much bentonite you're putting in and just throwing in your bucket with your cement, which I see quite often, what you'll wind up doing is that certain types of bentonites and that, because of the polymer coating on there, will turn the cements into more like a bubble gum down below. They'll set on the surface where they can get rid of the water, but anything in a contained spot, they tend to set like a bubble gum. And they really don't go into a set. It takes about 2 to 3 weeks to get them set up after that. Okay, this gives you a rough idea. If you got 0.65 US gallons fresh water for every percent bentonite added. Okay, if you want 5% bentonite, it'd be 5 times 0.65, so you'd have to add 3¼ US gallons. The reason everything, just so this was brought up, asked earlier, why on the bags, yes, we have the metric, and why is everything in US? Because that's where it's manufactured. That's where the best deposits in the world, which are in Wyoming, are, and they always do base everything, oil patch, doesn't matter where you go in the world, is based on US gallons per barrel. And that's why that is. And what it is you've got your bentonite. The additional wire required for bentonite is, for 5% bentonite by weight, is 3¼ gallons. You'd have your cement is 4.9. You add those two together, you need a total of 8.15 US gallons of water for cement at 5% or cement with a 5% bentonite added to it. That slides in your thing, so you don't have to memorize it, but just gives you an idea of what you have to add in order to make this thing work. Hole volumes, pretty straightforward in this situation or whatever. All it is you take the diameter of your hole and you can square it. So if it's a 10-inch hole, it's 10 by 10. 10 times 10 is 100. I always round up in the field. If you got your calculator handy, you can do it. So it's 10 times 10 is 100 divided by 25 is 4. So it's 4 gallons per foot of material or fluids or whatever to fill that extra space. If you have a pipe or a casing in there, all you do is you take your casing side, you multiply the two numbers, subtract them out, and that'll give you your volume of what you're going to need for your unit. Okay, we'll go through this. That's another way of calculating it out. Just take your diameter square, the easiest way. These slides are in your presentation, or in the handout there, but what it is these just a conversion. 1 cubic meter is 1,000 liters, 1 cubic yard is 27 cubic feet. You want to convert, this is the thing, if you're going from a liquid, you've done your whole volume calculation, okay? And it's a 10-inch hole, we want to fill it up with dry material. What you do is you divide, you have 4 gallons, right? Well, 1 cubic foot is 7.40 gallons. It's pretty easy to do your math on these things, or figure out how much material you're going to need, dry material. When you're doing anything with grouting, and that, I'll be very straight with you, and nothing, don't take this personal, drillers, but I know every one of your hole is perfectly gauged from top to bottom. There's no deviations or anything like that in your holes. But, and I know that, but if you happen to run into an area where this could happen, what typically it is by volume is around 10%. Is it when you're ordering product or even doing a big job and you know you're going to be doing some garbage ground, or there's a lot of different lenses and layers in there. If you're running high air or even mud rotary, and you go through there and you're doing a transition from one zone to the other, that's typically where you're going to have your washouts. If you're sitting on a zone or something like that, you have to pull the hole, that's where you're going to get your deviations at. And I know it doesn't happen, but just in case. Okay, this slide's pretty well redundant, but it gives you an idea how everything calculates out. On the back of manufacturer's bags, or they have these all over the place, if you want to figure out hole volumes and things like that, there's always a chart. And the annulus has to be done, is where you run your tremulino down the outside of the casing, and you wind up, because they say that you got to seat the shoe into the formation. So that's your seal, competent seal, and then what you do is you grout from the bottom up. Always remember, if you're doing a pumpable grout, or even cement, if you're trimming, okay, and you're doing an outside grout job, is try to leave your trimming line buried at least 5 to 10 feet. Cement, I leave it 5, grout, I'll leave it 10 feet. But what it is you've got to purge the hole. So any garbage upside on the formation or anything that's in that hole, you want to make sure you lift and bring to surface. That is critical. Cement or bentonite, it doesn't matter, you've got to bury that terminal. Keep that terminal. If you yard her up and shove her down, and that grouting, especially with bentonite, if you're running a heavy bentonite or you're having issues with it setting up quick on you, what you'll do is you get pocketing of air. When you shove it back down, you'll have air entrapment, and if it's midway in there, you'll never get it. You'll never purge the hole enough or get enough rolling in the bentonite to get all the air pockets in. This is what you want to see. Whatever's in your hopper has to be what you see, whether it's cement or bentonite, has to be what you see to surface. When you see it watery, and it just drives me right sideways, I could just walk on water when I see it. Is everything going good on the grouting? Everything Cadillac? The first time they see some dirty gray water come to surface, shut her down. We filled the hole. And no, you've got to purge it right to the top, because if you don't, that's when you're going to have subsidence happening, and you actually haven't done a proper grout job at that point. And it should be. Same consistency that's in your tank is there, and away you go. Okay, hole plug. They do mention using some plug-in in there, and this is a way that you can do it. You have to be patient when you're using hole plug. And the reason is that if you're not careful when you're using plug, you'll get bridging. I don't care. If you're in a hurry, don't even bother grabbing the hole plug. Even when you're using pellets, they're smaller and what, they will sink. They're really good for long distances. But the thing is do not start doing this type of dry installation, dry materials like plug or pellets in any borehole to seal it up if you haven't got time to do it. Because you get in a hurry, you're going to wind up bridging off, and once you bridge off, you're done. It's a bad day. Anyways, what it is, and the best way, and guys are starting to catch on to this out west. It took a while, but because they really were starting to push plug, they needed some higher percent solids and a lot of work that they were doing in some wells, water wells. And what it was is they spec'd in a hole plug. that type of material. 3/4 or 3/8, it's contractors. And the guys just put their barrel up like that, hooked their screen on with tabs, just ran it down there, nice and steady. Any of the fines, what happens is the whole plug just think of gravel, but when if they get handled or the bags are in the back of the truck, they rub together and it's detonate, so they start to break down, or powder rubs off on them, and it's that stuff there you don't want going down the hole, because when it hits the water, and that what it winds up doing is it lays off a layer, we'll just call water scum or whatever, and the pellets or the whole plug won't break through. And that's what causes it. Unless you dump a whole bag in 10 seconds or whatever, then you cause your own problems. But majority of the bridging is caused by the powders. Okay? Same when you're doing pellets and that, I always tell guys, the best thing to do is to pour the pellets if you're going to pour from the bucket, when you get towards the bottom, and I mean the last quarter of the bucket, you want to screen them some way or another, because pellets, like anything, if they're handled or thrown around a lot, because it's a pressed material, what they do is you get a lot of fines in there. Okay? And then this is what you don't want to have happening, because the bridging in there, that happens all the time. Any dry material, if you want it to work properly, straight up, it has to be placed into water. You've got to have a water-bearing formation. If you just pour a bunch of hole plug into a hole and have dry around a casing or whatever, and the hole is dry, and over time the water table will come up and get hydrated, all it will do is it will hydrate the outside, and the inside will stay dry. So it'll be like a big donut. Everything on the inside is dry. You won't have a proper confident seal. You always want to place anything like whole plug or pellets in standing water. Okay, testing water. Big thing is when you're using bentonites, not so much, well, bentonites or cement. Bentonites, you need a pH of around 8.5 to 9. Add soda ash. Pretty simple. One hit wonder, treat it out. As soon as it hits it, the pH comes up. On the other side of it, you've got to take out the hardness. Well, when you add soda ash in, think of it as a teeter-totter. You got high calcium or whatever hardness in the water, and you've got low pH. When you add the soda ash, what it does is it precipitates out the calcium, attaches on the calcium, drops it out of the system, makes it inactive, and it brings up the pH. It's like a teeter-totter. Okay? And that's how it works. Soda ash is a quick way of dealing with it. Adjusted for calcium. Temperature awareness for cements, and that warm water, either cements or bentonites. Warm water tends to stimulate things a little bit. Bentonite, if the water is really warm, it's been sitting in the sun in a barrel, you put it in your tank and pour it. What it does is it speeds up your hydration. We've gone from a 7 to 9 minute window of working, right down to probably about 4 or 5. So that's the time you grab the bag, you put it in, get it mixed, pump it down the hole, have it full, and start the batch. You have to keep it close. You've got 5 minutes to keep that pipe trimmed along, or it's going to be fluctuating. Water has a lot to do with it. And like I said, and I can't stress this enough, if you want to grout, I don't care if it's cement or bentonite, figure out your water volume, mark it on the tub or whatever you're using to mix in, and then just build up to that level. It's so many bags of this, and down the hole it goes. If you're consistent, you'll be efficient. If you're not consistent, it's a bad day. Okay, mixing bentonite grouts, like I said, 8.5 to 9. Hardness, you want to try to get around 100 ppm. 250, once you're over 250, you start, when you're mixing bentonite, if you notice when it hits the tank, when you're pouring it in, it goes into clumps. When you grab the clumps that are floating around, you break them, they're dry on the inside, that's hardness. Okay? You gotta remember, bentonite is a positive charge, or sorry, a negative charge, and the calcium is a positive, so it's like a magnet. If the calcium's too much calcium or hardness in the water, what it does is it just causes it to come together in clumps. As soon as it hits the water, it'll pull together like a magnet and file, and that's why you get dry clumps in there and that'll never break up. It's a hardness issue. Just add more soda. Another cupful, coffee cupful, and you should be good to go. Be ample for treating a 24 gallons. And sodium carbonate, not bicarbonate. You can get sodium bicarbonate anywhere. You go into a farm store, they'll sell you sodium bicarbonate. It has to be sodium carbonate. Okay, difference. Okay, water chemistry we've already gone through. Excessive chlorides. this is the one, chlorides have a cumulative influence. In other words, there's more than one thing that happens when you have a lot of chlorides in the system. Hydration and permeability, and what it does, very basically, is chlorides, once you're over 1,500, once you're over 1,500 on your concentration rate with chlorides, what it is over time, the bentonite will start to break down. It starts to eat away at it and it breaks it down. It turns it into a powder. It does, it dissolves it. When you get to a hardness of over 500, when you're talking about hardness, and that's excessively hard water when you're dealing with bentonites or anything like that, what it winds up doing is it clumping, you'll never be able to pump it. You're wasting your time. In both situations, if you're like that, go to a cement. If you have to seal up anything to do with chloride, different zones you've drilled through, you got fresh water and you figure you're going to take her a little further, and then you, for whatever reason, you go down a little bit more and you hit a salt zone or something like that, or you want to isolate zones, cement them off. Don't fool with bentonite. Bentonite is what I'm involved in, but I don't care. Anything to do with chlorides, that type of situation, go to a cement grout. Or if you've got to drill through a zone or you want to seal a zone, seal it with cement, drill through the cement. That's the only way that you can deal with chlorides. Okay? Very quickly, this slide's been around for eons, but anything to do with a bentonite-based grouter or mixer, you have to have paddles. Running it through the impellers of a pump just causes the bentonite particles to break up, you expose more surface area, and it flash sets on you. When you're mixing this stuff, you don't want a vortex happening like the old toilet bowl. What you want is it just moving around to the point where the whole tank is rolling, about 40 RPM, 40, 45 RPM in that. The big thing is when you're pumping a grout, do not ever shut off your paddles. If it's state, they tend to go into their set, or you speed up the set process. Okay? Prepare small batches. This goes to the whatever size your system. You try to stay with batches that you can handle, and be accurate with your water. Effective placement. The whole deal with bentonites, and that when you're doing any of these wells, because it states very clearly you have to do the outside of the casing from your shoe up, a meter, is you got to place it down there. And some of your wells are fairly deep around here, like you've got a long way to pump them. And that is you want to get them down there in situ, which means in as liquid state as possible, so when it stops moving, the grout stops moving, it'll start setting. You don't want to start setting in your tremulon. It's a bad day. Do not overshear mix. Basically, when the bag is in the tank, doesn't matter if it's a two-step, easy mud bend seal, or a one-step quick grout, doesn't matter what kind of grout or whose it is. Once it's in there, usually mix them about 30 seconds. Not a minute, go for a smoke, phone whoever, play a video game, whatever you want to call it. The thing is 30 seconds, keep that impeller going, open the valve and down the hole it goes. Don't mess around. Okay, the big thing is when you're grouting or whatever, you want to have maximum volume and maximum flow. So the bigger the tremulon you use, the better off it's going to be. The lower your pressures are going to be, the easier it is to pump. Unless you do the old-fashioned thing and dilute it and say that's good, but we'll just work with that one. Okay, place grouting annulus under turbulence, high velocity. The faster it goes down there, the better job you're going to do. Especially the first couple batches that go in there that are going to be moving to surface and purge the hole. You want them in and moving so they pick up all the garbage and crap at the bottom of that and bring it to surface. Okay, that one's pretty well self-explanatory there. Safety and handling. We're on the home stretch here, guys, so everyone just pretend you're awake and do good here. All bentonite grout used for grouting or drilling water phase have handling instructions on the packaging. The big thing is it is the responsibility of the end user to be aware of the safety and handling for each product. Anything that you use is environmentally, because you're drilling the water well, people and all that stuff, is safe to handle. MSDS sheet, you have to have them now, and it doesn't matter what province you're working in, I don't care, anywhere in Canada. If there is an issue or whatever, the first thing they will ask is where your MSDS. Okay, and an MSDS has to be within, there's a date on the top, 5 years of today's date. Anything within the 5-year window on a bentonite is a good MSDS. They're updated every 3 to 5 years, but make sure that you have a current one. That's what they'll tag you on, as an outdated MSDS. Okay, now, in the regulation, they have this. This is one, and it's one of the few ones, regulations out there, that actually specifically state, NSF means Sanitation Foundation. This here symbol is the one, you've got to see this on anything you're using. I don't care if it's a drilling fluid, a foam, or your grout, or anything, it has to be NSF. And what that is, this is just pull plug, and I'm going to leave the microphone here, so work with me. All kidding aside, down in the bottom on anything, and it doesn't matter, generically speaking, you should see this NSF, and on the bottom here, ANSI Certified 60. And what that means, there are two different institutions that independently monitor the quality of the material and to make sure that they fall within the environmental compliance. If it has an NSF, ANSI Standard 60, that means it falls in the category of materials that can be used in potable water situations without creating any toxic residues harmful to man. If you don't have that on your packaging, you don't have that on your drilling fluids that you're using, you're just hanging yourself out to dry because you've got no support whatsoever. Your regulation stipulates very, very clearly NSF, and you've got to make sure, I know all the manufacturers out there of the different products, there's only 2 products out there, they're not used in the water well industry, that are very rapidly being pulled because they don't have that certification. And straight up, because the industry is just going with the, instead of the sue me attitude, let's just do it properly. And so everything's, any of your grouts are all NSF. You want to make sure your product, whatever product of choice you're using, states NSF, ANSI Certified 60. Okay? Now, this is a big thing when people are dealing with the public, and it's one of these things that's catchphrases, and this is very important that you understand that. Anything that is NSF and that is classified under the degradable. And what that means is over a long, long period of time, and we're talking 10s, 50s, whatever years, depending on the product will break down and revert to its natural state. Well, what's bentonite? Bentonite is clay. You can't break her down any further than that. The big thing with bentonite seals, at the end of the day, is keeping them hydrated, moist. They're always going to do their deal. The thing is where people, and this is catchphrase, everyone's, I don't mean to upset anyone that gets into the green movement, but they use the term biodegradable. And when you're using the term biodegradable, what you're saying to people is the material you're using down hole to either grout or drill has an organic substance in it that will feed the living organisms, any living organisms in the soil or whatever, and that's where you create issues. That's where you get a situation where you've contaminated a water stream or something like that. Always remember, if it has the NSF, that means it will be it's a bentonite-based material. Even the polymers are NSF and they're degradable, not biodegradable. As soon as you make the statement, no problem, ma'am, it's biodegradable, everything's good, we're doing with you well, you've just hung yourself out to dry. It's very, very important, if you remember anything on this, NSF, check your products, and that the stuff you're using, and this slide is in there, so if there's anything you want to think, that is what it is. A company will stand behind you as long as you're using the NSF or there's issues into the environment. This is when the company, a rep or whatever, whoever it is, they step in with the full force of everything they got in their labs to back you up if there's an issue. If there's anything that isn't NSF, and they find that it has a starch or guargum base in there, and that's only used in remediation work when they're trying to clean up old oil wells or spills of that, is when they use those materials. And that's just to feed, it's starch base so they can feed the bacteria. Once they feed the bacteria takes off and starts cleaning up all the pollution. That's how it all works in a nutshell. It's a biodegradable material. You will never get involved in that. Okay, NSF reduces the level of concern for an end user, the drill and convert client, and the regulator as to whether or not materials are fit to use in a potable aquifer. If any issues develop and you used an NSF, ANSI Standard 60 certified product, you can be sure that you do not have to contribute to you do not contribute to any issue at hand. You've done everything within the realm. Okay? What are we doing here? Right on time, we're in about 4 minutes. Anyways, Baroid or anything, just so you understand how this works, it's a third-party thing. These people, they do not announce, and anyone that's involved in it's worldwide, anywhere in the world. What they do is they just walk into the warehouse and they say, oh, see that bag up in the corner? I want the third one down in the skid. The one coming off the conveyor, I want that one there that the guy's got in his hand, and I want those 4 skids there off that truck that's being delivered. That's how it works. They take the products out, and they let you know within 30 days whether that product, and you have to reapply, and it takes close to 2 years to reapply if you have any issues with your NSF certification per product. Every 3 years, it's $1,200. You have to 3 to 5 years, you have to recertify them. If you don't, that product cannot be sold until you go through the process again. It's very stringent, and it's one of the few systems that universal around the world is recognized and it's complied with. Okay? If you got any questions or there's an environmental issue that hits your thing, you phone the manufacturer and it's up to them then to step in and help you out. Okay? Any questions? Good. This is my contact number. I didn't put it in there. But if you guys ever have any issues in the field or whatever, just call myself. A lot of people in this room have phoned me from sites and they quick question just to make sure everything's dialed in properly. If you're ever looking, if you want information or whatever type thing, and it's not something urgent, just send me a quick email and I'll send it off to you. And on that note, I'd like to thank you all for your patience and for putting up with me. Have a good show and take care.
Okay, gentlemen, ladies, trade shows are over, but I don't like to, I'll ask you if you want, you guys stay, the trade show booths are still open. Tonight, we are having a meet and greet here. The trade show booths will be open again at 7 o'clock. We have entertainment with seafood chowder, a couple of complimentary drinks. But please go and visit your trade show booths or enjoy. Thank you all for coming and hope to see you tonight in AGM's Forum. Please don't run out the door.